Hello everyone, in this video I'm going to explain infinite series. This video contains a short introduction for infinite series as well as test for convergence. Here I will be explaining Cauchys root test. If you are watching my video first time and if you have not subscribed my channel yet, subscribe this channel to get more videos which I'm going to upload further. Similarly, if you like this video, just press like button in the YouTube channel. Let u1, u2, u3 be given sequence of real numbers. Suppose we define s1, s2, s3 by s1 equal to u1. s1 means first term of given sequence. s2 equal to u1 plus u2. That means sum of two terms in a given sequence. S3 equal to u1 plus u2 plus u3. That means S3 is written like sum of first three terms of a given sequence. Similarly, we can define S4 as u1 plus u2 plus u3 plus u4 and so on. Then S1, S2, S3, etc. form a new sequence whose nth term is Sn equal to u1 plus u2 plus u3 plus etc. un. So we have defined a new sequence like S1, S2, S3, etc., Sn, etc. Now, U1 plus U2 plus U3 plus etc. plus Un plus etc. That means it continues up to infinite term. Containing infinite number of terms is called an infinite series. So here we have definition for infinite series. So u1 plus u2 plus u3 plus etc. plus un plus etc. it continues. This is called as infinite series. And we denote infinite series like sigma n from 1 to infinity un or summation un. This is the notation for infinite series. And un is the nth term of infinite series. Now, let me define a concept of convergence, divergence, and oscillation of a series. A series sigma un is said to be convergent if limit n tends to infinity, Sn is equal to L. What is this Sn? Just now we have defined Sn means it is u1 plus u2 plus etc. un. Sum of first n terms of a given sequence. That is what Sn we just now defined. So if limit n tends to infinity, Sn is equal to L, where L is a finite quantity, then we say that given series sigma un is convergent. Similarly, if sigma un is said to be divergent, if limit n tends to infinity, Sn is either plus infinity or minus infinity. That means when we apply the limit as n tends to infinity to Sn, if you get infinite infinity plus or minus infinity, then we say that given series is divergent. Similarly, if limit n tends to infinity, Sn is equal to L or L dash. That means if you get more than one limit, then we say that given series is oscillatory. That means there exists more than one limit for a given series. So this is about convergence, divergence, and oscillation of a series. And we will see some example to discuss the nature of the series. First example, look at this. 1 plus 1 by 2 plus 1 by 4 plus etc. up to infinity. So we have to check the nature of this series. That means whether this series is convergent or divergent or oscillatory. And it is very clear that this series is geometric series. Look at the first term, it is 1. Look at the second term, 1 by 2. So here to get second term, 1 by 2 is multiplied to first term. Look at the third term, it is 1 by 4. So to get 1 by 4, 1 by 2 is multiplied with the previous term. Next term will be 1 by 8. That means here common ratio is 1 by 2. to get next term needed to multiply by 1 by 2. So this is geometric series with the first term 1 and the common ratio 1 by 2. Now Sn is equal to, how to define Sn, that is sum of first n terms, 1 plus 1 by 2 plus 1 by 4 plus etc. plus 1 by 2 power n minus 1. How did you get this 2 power n minus 1? Look at here. In the first place 1, or we can say 1 by 1. Second place 1 by 2. Third place 1 by 4. That means 1 by 2 square. Fourth place, what it will be? 1 by 2 power 3. Fourth place 1 by 2 power 3. Similarly, in the nth place, we can write 1 by 2 power n minus 1. Now, limit Sn n tends to infinity. We have to see whether this is finite quantity or infinite, or we get more than one limit. Limit Sn n tends to infinity, which means limit n tends to infinity 1 plus 1 by 2 plus 1 by 4 plus etc. plus 1 by 2 power n minus 1. Since when we apply the limit, this series will be sum to infinite terms because n is tending to infinity. So this goes up to infinite. We have formula for sum to infinite terms of an GP, that is a by 1 minus r. Here a is first term, r is common ratio. That means 1 by 1 minus 1 by 2. Simplifying, we get 2. So 2 is more, it is a finite quantity, therefore we say that series is convergent. Look at the next example. 1 plus 2 plus 3 plus etc. up to infinite. Now define Sn. Sn equal to 1 plus 2 plus 3 plus up to n. So up to n we define it as Sn. Now this is sum of first n natural numbers. We have a formula given n into n plus 1 by 2. Now limit Sn n tends to infinity. Obviously this will tends to infinity, or this is equal to plus infinity, because whenever n large is more and more, we get sum as more and more. So this is equal to infinite. So the series is divergent. Now look at the next example. 2 minus 2 plus 2 minus 2 etc. It alters. Nth term is minus 1 power n plus 1 into 2, because first term is plus, second term is minus, third term is plus. Similarly, nth term is minus 1 power n plus 1 into 2 plus etc. infinity. Sn equal to 2 minus 2 plus 2 plus etc. up to plus minus 1 power n plus 1 into 2. Now limit Sn n tends to infinity is 0 whenever n is even. So see here, whenever n is 2, if there are only 2 terms, 2 minus 2 is 0. If one more 2 is there, 3 terms are there, means we get sum as 2. If there are 4 terms, means so we get sum 0. So similarly, if you have even number of terms, then sum is 0, and odd number of terms, sum is, or the sum is 2. That means whenever n tends to infinity, Sn is 0 if n is even, and limit Sn n tends to infinity is 2 if n is odd. So here we get 2 limits for a single series. That means limit is not unique here. Therefore, we say that given series is oscillating. So here we have discussed 3 different examples. One is convergent series, another one is divergent, and third one is oscillatory. Now, whenever series are simple, we can easily just apply the limit and all, we can find the convergence or divergence. But whenever series is complicated, we cannot able to find the nature of the series directly. That time we have to go for some of the test for convergence. So here I introduce Cauchys root test. If sigma un is a series of positive terms, see here we are using this limiting this Cauchys root test for the positive terms only. Series should contain positive terms. And if limit n tends to infinity, un power 1 by n is equal to L. L is a finite quantity. Then the series is convergent if L is less than 1. That means this limit n tends to infinity un raised to 1 by n, if it is L and L is less than 1 means series is convergent. If L is greater than 1, then the series is divergent, and if L is equal to 1, this test fails. We have some alternate method to find the nature of the series whenever L equal to 1, but we restrict our study for the Cauchy's root test only. So we won't bother whenever L is equal to 1 what happens here. So in this video, I will be restricting only to check whether it is convergent or divergent, or whether test fails. Now, to continue with this concept, we need some standard results, limit results, which you already studied in your previous standards classes. So they are, I give some results. So limit n tends to infinity, n power 1 by n is always 1. Limit n tends to infinity, 1 plus 1 by n whole power n is equal to always e. And limit n tends to infinity, 1 plus x by n whole power n is always e power x. These three results are important result to utilize the formula of Cauchy's root test in the coming examples. Now let me explain this concept with some examples. First problem, discuss the nature of the series sigma n from 1 to infinity n square by 3 power n. Here n square by 3 power n. Remember, n power 2, 3 power n. Whenever the given series, nth term of the given series, if it is of the form f of n power g of n, that means in the power, if something is there, n is there, then we prefer the Cauchy's root test. The Cauchy's root test here. So un equal to whatever given nth term, it is un, n square by 3 power n. Now first step of Cauchy's root test is taking un power 1 by n. So n square by 3 power n whole power n, which means n power 2 by n divided by 3. Which means we can write, we know that a power m power n is equal to a power mn. So here 1 by n, let me separate, and 2 have written like this, n power 1 by n whole square by 3. Now applying the limit n tends to infinity un power 1 by n, because our definition or the way of checking convergency or divergency by root test is this way. So limit n tends to infinity un power 1 by n is equal to limit n tends to infinity n power 1 by n whole power 2 by 3. Already we simplified this part. Here 1 by 3 is constant, and we know that limit n tends to infinity n power 1 by n is equal to 1. We have seen this result in this video. So let me replace this limit n tends to infinity n power 1 by n as 1. So here n power 1 by n whole square. So I have written 1 square. So 1 by 3 is constant into 1 square, which is 1 by 3, which is less than 1. So by Cauchy's root test, this sigma un is convergent, because Cauchy's root test says that if this limit is less than 1, then the series is convergent. If it is greater than 1, it is divergent. And if it is equal to 1, then the test fails. Here it is 1 by 3 less than 1, so the series is convergent. Explain the next example. Test for convergence for sigma 1 plus 1 by root n whole power minus n power 3 by 2. Here also we can easily choose the Cauchy's root test, because here some expression, that is 1 plus 1 by root n whole power something is there in terms of n. So whenever we have one function, if I consider this as one function to the power another function in terms of n, then we prefer the Cauchy's root test. So here let me choose the Cauchy's root test and let me define un. Given nth term of a given series is this one. Now un power 1 by n, that is 1 plus 1 by root n whole power minus n power 3 by 2 whole power 1 by n. Here we know that a power, if I take 1 plus 1 by root n as a, power m, if I take minus n power 3 by 2 as m, power 1 by n. This is n. A power m power n can be written a power mn. Similarly, this is taken m, this is taken n. So therefore, let me write minus n power 3 by 2 into 1 by n. And just let me consider this part. Let me simplify this power part first, then apply this power to the expression. Okay. So minus n power 3 by 2 into 1 by n. Let me see what is this. And minus is taken out. N power 3 by 2. We can write n power 1 by 2 power 3. Here also again a power m power n. That is this property. A power m power n is taken a power m into n. This property is used here. So n power half power 3 can be written n power 3 by 2. So I have applied this property in reverse. Into 1 by n as it is equal to minus, we know that n power half is root n. So root n power 3. Root n power 3 can be written root n into root n into root n. So written root n into root n into root n into 1 by n. And also we know that n is equal to root n into root n. So root n into root n, if I substitute here, that cancel with the numerator and remains minus root n in the numerator. So this power simplified like this. Let me use this result. Like un power 1 by n can be replaced 1 plus 1 by root n whole power minus root n, which is equal to, since power is minus, we can write 1 by of 1 plus 1 by root n whole power n, because we know this property. 1a power minus m, we can write it as 1 by a power m. This property I have used here. So 1 by 1 plus 1 by root n whole power n. Now let me apply the limit. Limit n tends to infinity un whole power 1 by n is equal to limit. Here I have taken root n tends to infinity because we have expression 1 plus 1 by root n. And it is very clear whenever n is tending to infinity, root n also tends to infinity. Therefore, I have written root n tends to infinity, which is equal to, we have a result whenever limit n tends to infinity, 1 plus 1 by n power n is equal to e. Here instead of root n, instead of n we have root n. Therefore, this limit also tends to e. Therefore, limit root numerator is 1. So limit of numerator will be 1 because it is constant. Limit of the denominator is e. We know that if we have function in numerator and denominator, we can apply limit to numerator, which is 1, limit of denominator, which is e. And e is something 2.7 and 1 by that value is obviously less than 1. Therefore, this limit is less than 1. Hence, by Cauchy's root test, this is not theorem. Hence, by Cauchy's root test, sigma un is convergent. See the next problem example. Discuss the nature of the series sigma n from 1 to infinity n plus 1 whole power n x power n divided by n power n plus 1. Take un as it is given and un power 1 by n. Let me split it. First expression n plus 1 whole power n power 1 by n into x power n power 1 by n divided by n power n plus 1 is written n power n into n power 1, because we know that a power property a power m into a power n can be written as a power m plus n. This property is used here so that n power n plus 1 is written n power n into n power 1 whole power 1 by n. Simplifying, n plus 1 x and n into n power 1 by n. Now applying limit as n tends to infinity, un power 1 by n is equal to limit n tends to infinity n plus 1 x divided by n into n power 1 by n as it is written, which is equal to, here n plus 1 is there in numerator, here 1 n is there. Let me take n outside from the numerator. What we get? Limit n tends to infinity n into 1 plus 1 by n divided by n into n power n by n into x. So x n from the numerator and denominator get cancelled, remains limit n tends to infinity is of. So this limit of n tends to infinity 1 plus 1 by n into x divided by n power 1 by n. Now we have limit of numerator divided by limit of denominator. We can apply limit separately, and we know that limit n tends to infinity 1 plus 1 by n is limit 1 plus 1 by n, here directly applying limit. So limit of 1 is 1, limit of 1 by n whenever n tends to infinity is 0. So this is 1 into x will be x is constant, and limit 1 n power 1 by n which is equal to 1, we have a standard result. Therefore this limit is equal to x. 1 plus 0, because limit of 1 by n is 0, divided by 1 into x, which is equal to x. Now here x is unknown. So we define the characteristic or nature of the series by looking at the character of this x. So thus by Cauchy's root test, sigma un is convergent if x is 1, because we have Cauchy's root test like if the limit or limit n tends to infinity un power 1 by n value is less than 1, then it is convergent. So here that limit value is x. So if this is less than 1, then the series is convergent, and if it is greater than 1, then the series is divergent, and if it is equal to 1, then this test fails here. Let me move to next example. Problem 4. Find the nature of the series 1 plus 2 by 3x plus 3 by 4 square x square plus 4 by 4 cube x cube plus etc., where x is greater than 0. Here nth term of series is not given. First we have to write nth term of the series. How we can write? Look at the first position, it is 1. Second position, it is 2 by 3x. Third position, it is 3 by 4 whole square x square, etc. Second position, x power is 1. Third position, x power is 2. Fourth position is x power 3. And 2 by 3. If you just properly observe this one, so it is very easy to write the nth term if you just neglect the first term. So if you neglect the first term, we get the nth term. We can write first term is, we will consider as 2 by 3x. That is first place 2. Second place, see here 3 whole power 2 is there. Third place it is 4. So nth place we can see it is n plus 1. Similarly divided by first place it is 3. Second place it is 4 whole square is there. It is 5. So we can write nth place in the denominator n plus 2. and first place whole power 1, second place whole power 2, third place whole power 3, nth place it is whole power n, and x power n in the nth place. So we ignore the first term, and also if you ignore the first term, there will not be much more change for this series because it continues up to infinite. So if even if we ignore the first term, there it doesn't matter. So we used to ignore the first term only whenever we feel difficult to write the nth term and we feel difficult to proceed. So for such a series only we ignore the first term. So un equal to nth term we can write n plus 1 by n plus 2 whole power n x power n. Now un power 1 by n is equal to n plus 1 divided by n plus 2 into x, because power n cancel with 1 power 1 by n. Now applying the limit, we have n plus 1 by n plus 2 x limit applied to n tends to infinity. And numerator we take 1 n outside, denominator take 1 n outside, cancel. So numerator remains 1 plus 1 by n, denominator remains 1 plus 2 by n. So when you apply limit as n tends to infinity to numerator, limit of 1 is 1, limit of 1 by n is 0, and limit of 1 is 1 in the denominator, limit of 2 by n is 0 in the denominator, and x is there. So this is 1 by n, 1 by 1 into x, which is x. So we get the limit value as x. Now by Cauchy's root test, sigma un is, we will define the character or nature of the series by just defining the x. If it is less than 1, x is less than 1, then the series is convergent. If x is greater than 1, then the series is divergent, and if x is equal to 1, then series is, here test fails. So this is all about. Thank you for watching.